Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So I received the message from the audience that the 2025 IMO problem is released on the geometry one, and I look at the problem. I solved that problem, and I think this problem is not as difficult as the one we solved in 2011 IMO. But this is still a very interesting problem, and I think we want to explore this problem, solve it, and expand it. Okay, let's start. Let omega and gamma be circles with centers M and N. So here is a figure. We have one circle here, another circle here, centers on M and N, respectively, such that the radius of omega is less than the radius of gamma. Suppose omega and gamma intersect at two distinct points, A and B. So we can see A and B here. Line MN intersects omega at C and gamma at D. So we have the two circles, which we call omega and gamma, and the center at M and N. And we can see these two circles intersect on A and B. Line MN intersect circle omega on C and gamma on D, so that C, M, N, D lie on M, N in that order, right? C, M, N, D. Let P be the circumcenter of triangle ACD. So for here, because we want to know that P as a circumcenter of the triangle ACD, so basically I just draw the perpendicular bisector of AC, AD, and CD, right? So you can see this line here, and this line here, they meet on the point P, right? P is a circumcenter of the triangle ACD. Line AP meets omega again at E, which is not A, and meets gamma again at F, which is not A. So we have the line AP. AP meets omega on another point E and meets gamma on another point F, right? Let H be the orthocenter of triangle PMN. H be the orthocenter of triangle PMN. So you can see, because this line is an angle, this line is a perpendicular bisector of CD, so of course it's altitude in the triangle PMN, and this is perpendicular to NS is perpendicular to MP, and MT is perpendicular to NP. So this H is the orthocenter of the triangle PMN. Prove that line through H parallel to AP is tangent to the circumcircle of triangle BEF. So we want to prove that a line passing through H and in parallel with AP is a tangent line to the circumcircle of triangle BEF. Okay, so for the problem like this, the first thing we want to start with is to check on what's the property to make H. Here I mark the tangent point as G. Okay, so what's the point, or what's the property we can find that if HG is a tangent line of the circumcircle of triangle BEF, and also HG is in parallel with AP. So the direct thing we can get is to connect EG and FG, right? So based on that, we know angle EGH equals to angle EFG. And because HGA, so we just want to have some property or conclusion based on the things that we want to prove, and we can go the reverse way to do the proof, right? So just to check on this first as a start. Assume that HG is a tangent line and also is in parallel with AP, and let's see what we can get here. Then we know that this angle, the angle EGH, equals to angle EFG, and also angle EGH, because HG is in parallel with AP, so HG, the angle EGH equals to angle GEF, which means the triangle GEF is an isosceles triangle, and we get GE equals to GF, right? So keep this in mind. That's what we can derive from the problem result. And we want to prove that HG is in parallel with AP. So before we try to prove that HG is in parallel with HG is a tangent line of the HG is in parallel with AP, and it's a tangent line of the circle BEF. Before we do that, let's just take a look at this figure. Okay. Here is a figure I simplified, which I remove that H and G out. Instead, I directly connect ME and extend it. I connect NF meets ME on a point. I call it G. So now let's look at this figure and just remind ourselves what's the problem set here. So we have a circle. Let's just call it circle M, okay? We have a circle M, we have circle N, and we know P is, we know that C, M, N, D are on the same line, right? That's a line connect to the centers. And we know that P is a circumcenter of the triangle ACD. And when we connect AP meets the circle M on E, meets the circle N on F. And we connect ME and extend it. We connect NF. We find the point G here. That is the intersection point of ME and NF. Okay, now let's look at the properties. So first think about this point. This point is a key point here because this is a circumcenter of the triangle ACD, which means PC equals to PA equals to PD, right? So PC equals to PA equals to PD. So from PC equals to PA, we get that angle PCA equals to angle PAC. And because M is on the perpendicular bisector of segment AC, that means we already know that this angle equals to this angle, right? The angle MCA equals to angle MAC. Either it's in the circle M or M is on the angle M is on the perpendicular bisector of segment AC. We can get the same conclusion. Then we get the results that angle PCM equals to angle PAM. Right? So we get this angle equals to this angle. And remember that PA equals to PD. right? PA equals to PD, and NA equals to ND. So we know that angle PAN equals to angle PDN. Right, because PA equals to PD, so this angle, the angle PAD equals to angle PDA. And because NA equals to ND, so angle NAD equals to angle NDA, which means angle PAD equals to angle PDN. Oh, sorry, angle PAN equals to angle PDN. And because PC equals to PD, right? So we know that angle PCM equals to angle PDN. Right, that's what we get. So angle PCM equals to angle PDN, which means angle PAM equals to angle PAN. So angle PAM equals to angle PAN. These two angles are equal. Okay. So these two angles are equal. Now we connect AB. Right? So we see that angle PAM or angle MAP equals to angle NAP. These two angles are equal. So we can write that we want to find the angle of BAE, right? Because we know that angle BAE relates to the angle ACM and angle ADM, right? So we just want to prove that. The angle MAP equals to angle MAB plus angle BAE, right? And angle NAB, angle NAB equals to angle NAB equals to angle NAP plus angle BAE, right? And we know that angle NAP equals to angle MAP. So just replace MAP into this one, then we get angle NAB equals to twice of angle BAE plus angle MAB. Right, so we get angle NAB equals to twice of angle BAE plus angle MAB. Right, and what is angle MAB? Angle MAB equals to angle MAB equals to 90 degree minus angle AMN, right? Because AB is perpendicular to CD. So angle MAB equals to 90 degree minus angle AMN minus this one. Then we got angle MAB. Similarly, the angle NAB equals to angle NAB equals to 90 degree minus angle ANM. Right? Then we put this one into here. Then we have 90 degree minus angle ANM equals to twice of angle BAE plus 90 degree minus angle AMN. So we get angle AMN minus angle ANM equals to twice of angle BAE. Right? So angle AMM minus angle ANM equals twice of angle BAE. And what is angle AMN? That is twice of angle ACM. So twice of angle ACM minus twice of angle ANM. ANM is twice of angle ADN, right? ADN equals to twice of angle BAE. So we get that angle ACM minus angle ADN equals to angle BAE. Which means we just get that this angle, the angle ACM, minus this one, the angle ADN, equals to angle BAE, right? Which means we can think of it as this way, that the angle, the circular angle reference to the arc AJ, which is the angle ACJ or angle ACM, right, equals to the circular angle reference to the arc AI, right? That is angle ADM plus the circle, actually plus the angle BAE, which is a circular angle reference to arc BE in circle M or arc BF in circle N. Right, that's the same angle, BAE or BAF. Then we can get the conclusion, because BJ equals to the arc BJ equals to arc AJ, which means we get that the circular angle reference to the arc EJ in the circle M would equals to the circular angle reference to the arc AI, which is BI in the circle N. Right. Basically, what I'm saying is that from here we get the angle ACM minus angle actually let me write it this way. The angle AMN minus angle EMN equals to angle BME, right? And equals to twice of angle BAE, which can be considered as very obvious, right? So the angle AMN, which is angle BMN, right, minus angle EMN equals to angle BME, which is twice of angle BAE. Okay, so basically what we get from here is that this angle minus this angle equals to this one. Okay, equals to this one. Now let's think about what we just did. We have angle here, the angle EMN, this one, equals to twice of angle this one, right? So the angle EMN equals to twice of angle ADN, or equals to angle ANM, right? This angle equals to this one. Let me see. So let's just this one equals to this one. And also angle AMN, which is twice of angle ACN, right? It equals to angle MNF, right? So this one, 1, 2, 3, equals to 1, 2, 3, equals to this one, which means AMGN is a parallelogram, right? So we get that AMGN is a parallelogram. That's awesome. Because now if we look at this angle, the angle FEG, this angle, right? Let me call it alpha. The angle FEG equals to angle MEA, right? Which is alpha. And this one equals to angle MAP, right? And for the angle EFG, it equals to angle, because NF equals to NA, so the angle EFG equals to angle NAP, right? So this is beta, which means alpha equals to beta, right? Because this one, the angle MAP equals to angle NAP. You get it? This one equals to this one equals to this one. This one equals to this one. So, because this one equals to this one, and we know that alpha equals to beta. So, which means we find that EG equals to FG. Right? And now we want to prove that this point G is on the circumcircle of the triangle BEF. Right, we just find that EG equals to FG, which can remind you this might be the point we were looking for, right? The tangent point, because if all that problem result can be true, then we have the similar conclusion that EG equals to FG. And now we find if we directly connect the ME and NF, we can find this point. Now we just need to prove that this point is also on the circumcircle of the triangle BEF, right? So if we look at the angle BEF, it equals to angle BCA, right? It equals to angle BCA equals to twice of angle ACM. Right? So the angle BEF equals to twice of angle ACM. And angle BFE equals to angle BFA, which is angle BDA. Right, so it equals to angle BDA, which is twice of angle ADN. Right, that means here, this angle plus this angle is twice of angle ACM plus twice of angle ADN. And if we look at the angle EGF, we already know that these two angles are equal and they equals to the angle MAP, right? So we know that twice of MAP plus twice of angle ACM plus twice of angle ADN equals to 180 degree, which means the twice of angle MAP is here, right? That makes this angle, the angle EGF, to be twice of angle ACM plus twice of angle ADN. That's the angle EGF. And we know that this angle plus this angle is exactly twice of ACM plus twice of angle ADN. That means the angle EGF plus angle EBF equals to 180 degrees, which means EBFG are cyclic. So G is on the circumcircle of the triangle BEF. Okay, so we're just one step closer to what we have. Now, let's just remember all the stuff we get so far and think about the author center here. Right? So, we basically already know that in the, let me draw the, so we already know that this is BEF, for example, and we find a point G is on the circumcircle of the triangle BEF, and also EG equals to FG. So think about that. If we draw a tangent line that passing through G, right? We draw a tangent line of this circle on the tangent point G. Then we know that this angle equals to this angle. And also this angle equals to this angle. Right? Which means we already know that if we have a tangent line on the point G, then we know that this angle, the angle EG, whatever here, EGX, equals to angle FEG. Right? And we calculated for the angle EGF. Angle EGF equals to twice of angle ACM plus twice of angle ADN. Which means angle FEG equals to half of 180 degrees minus twice of angle ACM plus twice of angle ADN, which equals to 90 degrees minus angle ACM plus angle ADN. Right? That means the angle EGX is a fixed number. Angle EGX equals to 90 degrees minus angle ACM minus angle ADN. Right? That is a fixed degree. So, for this problem, because we want to prove that HG is a line that in parallel with AP, and also HG is a tangent line of the circumcircle of the triangle BEF. Therefore, we just need to calculate for the angle EGH, right? If the angle EGH equals to angle EGX here, that means H is on the tangent line of the circumcircle BEF as a tangent point G. Then we solve the problem. Now the question is, how can we calculate for the angle EGH? So remember that H is the orthocenter of the triangle PNM, which means we can get this angle, the angle MNS, right? One thing that we want to review here is that we know because H is the orthocenter of the triangle PMN, so we know that this angle, let me mark it here. So we know that this angle, the angle MNS, equals to angle SPH, right? And let me connect AB here. And remember that AB is perpendicular to CD. Also, PH is perpendicular to CD. So AB is in parallel with PH. Which means angle BAP equals to angle EPH, right? So this angle equals to this angle. The angle BAP, which is angle BAE, equals to angle EPH. And now think about this angle, the angle PCD. We know that angle PCD equals to angle PDC, right? And because angle PDC equals to angle PAN, right? PDN equals to PAN. So this angle actually equals to this one, right? The angle PAN, equals to angle PDN, which equals to angle PCN, right? The angle PAN equals to angle PDN equals to angle PCN, which means CANP are cyclic, right? CANP are cyclic. Similarly, we know that the angle MAP equals to angle MCP equals to angle PDM, which means angle MAP equals to angle MDP. So AMPD or DAMP are cyclic, right? So CANP are cyclic, DAMP are cyclic. So we can get that angle ADM equals to angle APM, and angle APN equals to angle ACN, right? Because ACPN are cyclic, so angle ACN equals to angle APN. And because AMPD are cyclic, so angle ADM equals to angle APM. So we find that the angle BAE equals to angle EPH. Then we find lots of equivalent angles here, right? Let me do this. So the angle MPA equals to angle ADN, and angle MPA equals to angle ACM, right? So we know that because angle ACM minus angle ADN equals to angle BAE, which is angle HPA here, right? That means the angle NPA, minus angle APH equals to angle ADM, which means this one, the angle here, this angle equals to this angle, right? Okay, why I want to do this calculation here? Just because when we have the orthoscopy here, we know this angle equals to this one, which is angle ACM, right? That helps us to find out the angles. So this angle equals to angle ACM. Look at here, this one equals to this one, which means AC is in parallel with NH, right? So we get here, AC is in parallel with NH. And also, what we have here for the angle NMH, this one, because this one equals to this one, right? These two are equal. This is 90 degrees, this is 90 degrees. So this angle equals to this angle, right? So this angle equals to this angle, which is the angle ADM. Then we get angle NMH equals to angle ADM. So we know that this one equals to this one, which means AD is in parallel with MH. Okay, now we have that this angle equals to this one and this one equals to this one. What about the angle NME? We know that angle NME, because AMGN is a parallelogram, right? We just proved that. We know that angle NME equals to angle ANM, which is twice of angle ADN, right? Angle NME or angle NMG is twice of angle ADN, which means MH is the angle bisector of angle NMG, right? MH is angle bisector of angle NMG. Similarly, the angle MNG equals to angle AMN, which is twice of angle ACM. And we know that angle MNH is 1 ACM. So angle HNG is another angle ACM, which means NH is angle bisector of angle MNG. So H is the incenter of triangle MNG, right? That means we can easily calculate for the angle MGH, which is half of angle MGN. And what is the angle MGN? The angle MGN is 180 degrees minus angle NMG and minus angle MNG. And we already know that angle NMG is twice of angle ADN. And angle MNG is twice of angle ACM. So the angle MGN equals to 180 degrees minus twice of angle ACM minus twice of angle ADN. Right? Which means half of it, the angle MGH equals to 90 degree minus angle ACM minus angle ADM. Look at these two. They're equal, right? Which means H is on the tangent line. H is on the tangent line passing through tangent point G of the triangle BEF. Okay, for now, we just prove this problem. Where HG, of course, is in parallel with AP, just because the tangent line passing through G is in parallel with AP because EG equals to EF. EG equals to GF, right? So for now, this problem is done. And I want to do some extension for this problem. Here, we also want to prove that CE, BD, and PH are concurrent on this point K. And K is also on the circle BEF, the circumcircle of triangle BEF. Right? Basically, we want to prove that KEBFG are cyclic. And also we want to prove that CE, BD, and PH are concurrent on this point K. So if we just think about it as this way, we find the point K that actually is the intersection point of CE and PH. Right, we find this point already. Then we just need to prove that BKD are cyclic. Sorry, BKD are collinear, right? We just need to prove that. And we know the angle BDI, equals to angle ADI, which is angle ADN. Right? And because K is on the perpendicular bisector of segment CD, which means angle KCD equals to angle KDC. Right? And angle KCD, angle KCD equals to angle ECJ. Which is angle BCJ minus angle BCE. And we know that angle BCJ equals to angle ACJ. And we know that angle BCE equals to angle BAE. And we already know angle ACJ minus angle BAE equals to angle ADC. So we know that angle KCD equals to angle ADN, which equals to angle BDI. Right, so KDC equals to BDC. That means BKD are collinear, which means BDCE and PH are concurrent on this point K. Now let's try to prove that K is also on the circumcircle of the triangle BEF. We can connect BK here, connect BK here. So actually let me think, what we can do is that we already proved that this angle equals to this one, right? So the CK is actually in parallel with AD, right? CK is in parallel with AD. And we know that BKD are collinear, which means angle BKE is twice of angle DCK, right? Or twice of angle ADN. So angle BKE equals to twice, because angle BKE equals to this one plus this one, right? So angle BKE equals twice of angle ADN. And we know that angle BFE equals to angle BFA equals to angle BDA, which is twice of angle ADN. BFE equals to twice of angle ADN. So we know that angle BKE equals to angle BFE, which means K is on the circumcircle. I mean, KEBF are cyclic. So K is on the circumcircle of the triangle BEF, right? We prove this. And similar thing for the CB, DF, and PH. DF, PH, and CB. So they're concurrent on this point L. It's exactly same as the way we proved for the K. So I'll just cut this, right? I just show the result. And another thing here, we want to prove that IF is in parallel with MP, and also JE is in parallel with MP. So think about IF. We want to prove that IF is in parallel with MP. Yeah, we want to prove that IF is in parallel with MP. Think about the angle NIF, right? We just need to prove that angle NIF equals to angle NMP, right? And we know the angle NIF equals to angle DIF, which equals to angle DAF, right? Angle DAF. So the angle DAF equals to angle NIF. And what is angle DAF? That is 90 degree minus angle BAE. Because AB is perpendicular to CD, right? So the angle DAF equals to 90 degree minus angle BAE minus angle ADN. Which equals to 90 degree minus angle ACM, right? Angle BAE plus angle ADN, that is angle ACM. So that is angle DAF or angle NIF, right? NIF is 90 degree minus angle ACM. And what about the angle JMP? Because this is 90 degree, angle JMP equals to 90 degree minus angle MPH, right? Minus angle MPH. And we just proved that angle MPA equals to angle MDA, and angle APH equals to angle BAP, which means the angle MPH equals to angle ACM. So it equals to 90 degree minus angle ACM. So we know that angle NIF, this one, equals to angle JMP, this one. Therefore, IF is in parallel with MP. We can use a similar way to prove that JE is in parallel with NP. Okay? And the next thing is that we want to prove CE, AB, and IF. Look at here, CE, AB, and IF are concurrent. Right, in the figure, I draw it concurrent on R. And also we want to prove that DF, AB, and JE are concurrent. So the method is that let's just neglect the CE for now, right? Think about that we have this R as the intersection point of AB and FI. Then we connect CR, right? If we can prove that the angle BCR equals to angle BCE, that means CRE are collinear, which means CE, AB, and IF are concurrent, right? Because R is the intersection point of IF and AB. Okay, so just think that R is the intersection point of IF and AB. Then we already know that AIBF are cyclic, right, on the circle N. So AIBF are cyclic. So we want to calculate for the angle JCR, right? Which we can calculate JCR as an angle JCB minus angle RCB, right? And because R is from here, from the intersection point of the IF and AB. So we know that this angle, the angle FAB, equals to angle BCE. Right? And then we can directly calculate for the angle JCR is actually equals to angle ADC. Similar for the next one, right? Okay, so basically that's all the extension and for solving this problem. I think what we have here and here, right? So for this problem, I think it's not as difficult as the one we showed for 2011. But I think this problem is very, very interesting because we can dig so many properties on the figure. Okay, I hope you like this video. See you in next one. Thank you.